All right, second page of lesson 3 for unit 1. Find the equivalent numerators of rational expressions. First, back out or divide the factor multiplied by the first denominator to get the larger second denominator as a product. Then multiply the numerator by that factor to get the equivalent or missing larger numerator. My apologies, excuse me. All right, that sounded very complicated. But that was using proper math terminology, okay? It says first back out or divide the factor multiplied by the first denominator to get the larger. In other words, we have this denominator right here. What did it get multiplied by to get this denominator? Okay? So you can think of it as a division problem, but this one's pretty easy. 6 divided by 3 is 2, right? 2 times 3 is 6. That's what the 3 got multiplied to make a 6, all right? Now it went from a to the second power to a to the fifth power, which means you must have multiplied it by what? 3 a's. Because remember, when you're multiplying bases that are the same, when you have a to the second times a to the third, that is the same as a to the 2 plus 3 or a to the 5, okay? So that means we multiply by a raised to the third power. And then to go from b to the third, this b is a 1, right? We needed 2 more. So b1 times b2 is b to the 1 plus 2, or b to the third, okay? So when we back out or divide the factor multiplied by the first to get the second, that's right there, okay? So apparently 3a squared b1 times 2a to the third b to the second is going to give you what? This times this is 6. I'm just checking. This times this is 5. And this times this is 3. Okay, so that's the factor that gave you this product. Okay? So that means if these are equivalent rational expressions, the same as rational fractions. Let's say if you had 2 over 7 equals what over 14? Well, 7 times 2 equals 14, so 2 times 2 equals 4. The 4 is what you're getting. So what we're going to do is multiply this by the common factor of 2a3b2. And what do you get when you do that? Well, 2 times 5 is 10. A to the first power times a to the third power adds their exponents. And that comes along for the ride. Okay, so that is my answer that goes in that spot right there. We're just making equivalent rational expressions, okay? So what is in this guy over here? This is plus 3 and 4. All right, what got multiplied by x plus 4 to get this number here? Well, it must have been x plus 3, okay? So whatever's here, you want to multiply by x plus 3. So this is going to be, you can put x plus 3 over x minus 2 as your answer. That's perfectly fine. Check with your instructor if they want you to then FOIL that together, right? This times this is x squared. This is negative 2x. This is 3x, this is negative 6, combined like terms, x squared plus x minus 6. So I guess you could put that as an answer. I don't require it. I think it's perfectly acceptable. Check with your instructor. But I'm pretty sure mom takes the math homework, takes that as an answer, okay? They're probably just going to want that part. And remember, we're not reducing these. Don't look at this and then go like that. I mean, the whole point was to figure out how to make them expanded, right? If you reduce them, you should get this back. So, unless you don't, you did something wrong, okay? How about this one? This is a perfect square minus a perfect square, a plus and a minus, and then the root is 4. 16, 4 times 4 is 16. All right, which means this one got multiplied by x minus 4. So this needs to be multiplied by x minus 4. So my final answer for this right here is 2 times x minus 4. That's all. Okay? This one, plus, 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 plus. So it's either 2 and 3 or 1 and 6. Since it's a 5, it's 2 and 3. So that means this one got multiplied by this. All right. If you do this and this number's not in there, you did something wrong here. Okay. So if you'd been a 1 and a 6, that wouldn't work because there's no way that's going to equal that. So that number should come up in here. So if you want to, what you can always do is start with that and go, I know that x plus 2 must be in there. What's the rest of it? Okay. So whatever that gets multiplied by, that gets multiplied by. So right there, my final answer is x plus 3x minus 4. And it doesn't matter if you put the minus 4 first or second, but that's what it is. Okay? All right. Identify the LCD and create two new equivalent rational expressions with the LCD as the denominator of both. First, identify the LCD. Then determine what factor each is missing, multiply the numerator by the missing factors, and create rational expressions equivalent to each of the original expressions. Again, that sounds kind of complicated, but that's math terminology for you. So look at this here. Here's a rational expression. Here's another one. Okay. What would be the LCD for these? Okay. Well, look at these. So I got a 4 and a 6. What's the LCD of a 4 and a 6? Well, that was 12, right? We did that before. And then the largest exponent. So out of the two b's, the 3 is there. And the a is there. And there's one c. So that is the LCD. Okay? That's the LCD. So eventually we want to both have that LCD on the bottom of each of these rational expressions. Okay? So that means we need to convert 4b3c into 12. So how do we get that? How do you go from 4b3c equal to 12a squared b3c? Well, 4 to the 12 is a 3, right? B to the 3 to B to the 3 means I didn't add any b's or didn't multiply any b's. And then 1c and 1c. So all I did was multiply by c. Oh, wait a minute. I need some a's. A squared. So that was the multiple. That was factor that got multiplied here. Okay? So if you take that 3a squared, that's going to convert that 4 into the 12. All right? And then if you do it to the top also, if you have 5a here and you multiply that by the 3a squared, you're going to get the 15a to the 3. Okay? And then you got to do it all again for this one. If you want 6a squared b to turn into a rational expression that has this on the bottom, what did it get multiplied by? Well, to get 6 to 12, that was a 2, right? A squared, that's the same, so no extra a's. But I upped my b's by 2, and it must have been a c involved. So that's the factor that got multiplied by this denominator to get the new denominator. So we want to take what we had, which was 3c, and multiply it by the same thing, so we're getting an equivalent rational expression. So 2 times 3 is 6. The b squared stays the same, and then c times c is c squared. So that's where this came from. Okay? So let's try one of our own. All right, so step 1, find the LCD between this term and this term here. So since 5 is a factor of 10, 10 is going to be my LCD so far, okay? And then that has a b squared, and that has a b. So I know I have a b squared, and that has an a3, so that's going in there. So that is my LCD. So that means I need to convert these to having 10a3b2 on the bottom, okay? So how do I go from 5 to that there? Well, there was a 2, right? 2 times 5 must have been 10. And then the same number of b's is there, but I must have multiplied by three a's, okay? So I want to multiply this one by 2a3, okay? This times this made this 10. This times this makes what? This is going to be 6, and then how many a's? We have 4 a's. Okay? All right. This one had pretty much all of that in there. It's just missing a b. So I need to multiply this by a b, because this got multiplied by a b. Okay? So this would be 2b, and we're done. Okay, I'm making 2 equivalent rational expressions using my LCD. All right, to find my LCD of these guys, I need to factor them first, right? All right, this is a negative and negative. That means this is a plus and minus. This is a positive, positive. That means that's 2 positives. All right, factors of -6 that add up to a -5. So since the signs are opposite, this is going to be a -6 and a +1. That would give me a -5. Okay. This one's a +3 and a +1. All right, so there's an x plus 1 and there's an x plus 1. So that's what they have in common. So I have, for my LCD, I have one of those. All right, and then one of everything else. So x minus 6, x plus 3. Okay, so that's the LCD that I need to convert everything else into. All right, I don't have a lot of room. Let me squish this in here. So I need to x plus 1, x minus 6, x plus 3, and x plus 1, x minus 6, x plus 3. All right, so those are what I'm going to convert these other ones into. All right, so the first one, which one is it missing? Let me fix this a little. I don't know if it's a little hard to read. I don't know if that's much better. All right, so they have the x1 in common. All right, so this term here has, or this rational expression has everything but the x plus 3, okay? So I need to multiply the top one by an x plus 3 because that's what this got multiplied by, okay? So what goes up here is 5x, x plus 3. Just leave them apart, it's okay, okay? And this one over here has the x plus 3, x plus 1, so it's missing the x minus 6 because this got multiplied by x plus 6. So this one's x minus 2, x minus 6. Okay, those are, this rational expression is equivalent to that rational expression. Okay, that's all we're doing. We're trying to make them, because you can imagine what we're working ourselves up to, right? We're going to have problems where we're supposed to add this rational expression to that rational expression, and you need a common denominator. So you have to make an LCD. You have to make equivalent fractions so you can add them. Okay, that's where we're going with all this. So let's keep practicing here. All right, so we have All right, they have no factors in common, so what's the LCD? If you have 4 and 7, you have to multiply them together. So my LCD is them multiplied together. That's all, okay? So if you're going to have to multiply this by x plus 2, then you need to multiply this by x plus 2. So this is going to turn into x plus 2 over the LCD, x minus 3, x plus 2. And let's just write this over here because the other one has to have the same denominator. All right, so this one had the x plus 2, but it doesn't have the x minus 3, so that's going to be multiplied by it. So this is going to be x minus 3, x minus 3. Okay, so just to sort of check and make sure we didn't go down any rabbit holes here, remember, they got multiplied by the same thing. So if they were gone, you should have what was here, all right? So if they were gone, you should have what was there. That's the whole point, all right? We turned them into something that had the same thing on the bottom. So if they were in a problem together, we could add them, okay? Because they have common denominators. All right, so let's see. This is x plus and minus. A minus minus is a plus and minus when you're factoring. 12 with, so this must be 4 and this must be 3. And this one here, x plus 3, 1 or 1, 3. Okay, either way. All right, so what they have in common is x plus 3. So their LCD is going to be, wait, let's write that somewhere else. I'm going to take up my only spot here. So the LCD is going to be x plus 3, x, that's what they have in common, x minus 4, and x plus 1. Okay, one of what they have in common, and then one of each of the unique ones. All right, this one, the first term, the first rational expression is missing the x plus 1. So this is going to be x plus 1, x plus 1. So this is going to be x plus 1, 3x plus 1, over x plus 3x minus 4, and, oh, wait, what are we missing? We're missing the x plus 1, x plus 1, x plus 3, yep, x minus 4. That's my LCD. Does it matter like what order? As long as I have x plus 3 somewhere, x minus 4 somewhere, and x plus 1. Remember, the order is unimportant as long as I mean, obviously you should keep it the same, but it's got everything it needs in there. All right, so this one's missing the x minus 4. So x minus 4. So this means to be x minus 4. So 2x, x minus 4. Okay?